Hi, welcome to Kepler's training video. This is the part 2 of the subnet calculation using decimal. I assuming that you have already watched part 1 of this video. So for this part 2, I will continue discuss some more common questions in the examination. And I will also discuss the cases for class B and class A. The other kind of question is that giving you two IP addresses, you need to check whether they are on the same subnet or not. In fact, once you know how to find out the subnet range, it shouldn't be difficult because you just need to check whether these two IP addresses are in the same range. For example, for 200.1.1.130/29 and the other one is .133/29, are they in the same subnet? The first thing is to find out the size of the subnet. So once again, we know how the technique, right? So find out the host bit first. For /29, it should be 3 bits for the host bits. Then the subnet size is 8 different address. Then find the multiple just less than say 130 first. This should be 128. Then the ranges is from 128 up to the, what is the last one? Okay, the last address is once again 128 plus the size minus 1, right, which is 135. So the second address also fall into this range. That means these two IP addresses are in the same subnet. Second example. First IP address 200.1.1.92/28. The other one is .130/28. Once again, find out the size first. The size in here is that the host bit is 4 bits. So the size is 2 to the power 4, which is 16. Notice that in this case, you don't even find out the subnet range. Why is it? If you notice the difference between these two IP addresses, which is actually 130 minus 92, that is 38, right? 38 is greater than the size, so they should be in different range. That means these two IP addresses are in two different subnets. Sometimes the question doesn't give you the prefix length. Instead, it gives you the subnet mask. Then how can we do the calculation? Do we need to first convert it back to the equivalent prefix length first? The answer is no. Once you have the subnet mask, it's very simple to find out the size of each subnet. You just use 256 minus the last byte. For example, the subnet mask 255.255.255.240. Then the size is you subtract 2 zeros from 256. That is 16. So once you get the size, I already tell you that you can do all the subsequent calculation. In fact, you can also use this method to convert back to the prefix length. Because for 16, it is 2 to the power 4. That means you have 4 bits as the host bit. Then the prefix length is 32 minus 4, which is /28. Reversely, you can also use this technique to calculate the subnet mask for a particular prefix length. So once again, find out the size first, which is 2 to the power h, right? H is the numbers of host bits. And then use 256 minus this size. Then you get the last byte of the subnet mask. For example, for the prefix length /29, you get 3 bits as the host bit. Then the size is 2 to the power 3, which is 8. Subtract 8 from 256, which becomes 248. So the complete subnet mask is 3 of 255 and then dot 248. If you're already familiar with the previous calculations, you shouldn't have any difficulty to tackle the other 2 more problems. The first one is that giving n hosts, then you need to put it into a sublet. Now you need to divide a network number into sublets so that the size of the sublets is just good enough to accommodate these n hosts. So what will be the correct prefix length? We call it that for h numbers of host bits, the sublet size will be becoming 2 to the power h. But because the first and the last address are not usable, so the usable address are actually 2 to the power h minus 2. That means you should find an h so that 2 to the power h should be greater or equal to n plus 2. Once you get the h, then the prefix length will be becoming 32 minus h. If you need to find out the sublet mask, remember that the last byte of the sublet mask is 256 minus the size, that is 256 minus 2 to the power h. Let's see an example. Say if you need to accommodate 13 hosts into a sublet, then because 2 to the power 4 is 16 is good enough, right? 2 to the power 3 is not enough, but 2 to the power 4 is 16, which is greater than or equal to 13 plus 2, right? So that means h is 4 in this case. Then the prefix length will be becoming 20h, which is 32 minus 4. The correct sublet mask is 255, 255, 255, that 240, because 240 is just 256 minus 16. Now you're understanding that the smaller sublet is /30. Because for this case there are 2 bits for the host bits. That means you have 2 to the power 2 for the size. But remember that the first and the last address is not usable. That means you have 4 minus 2. You have only 2 usable address. You can't have /31. Why is it? Because for /31 you only have 2 address. But then the first and last cannot be used. Then you don't have any address to be used. The second kind of question is even more trivial. It requires you to divide a network number into at least n numbers of sublets. Then what should be the correct prefix length? Then you simply find a 2 to the power s, which is greater than or equal to n. Then s will be becoming the numbers of subnet bits. I think I don't need to give you an example in this case. Some more hints. Sometimes you can use the parity to double check your calculation. Say for example, if somebody tell you that I found a broadcast address something like .130x, then you should immediately knowing that this is not correct. Why is it? If you notice the parity of the subnet number, the broadcast address, then you should able to understanding why is it. Now let's see. What should be the parity of the subnet number? Even or odd? It should be even, right? Why is it? In the binary point of view, the last bit is always 0. Then it is even. Then what about the broadcast address? From the binary point of view, the last bit is 1. That means it is odd. For the first and last available address is trivial. I think I don't need to explain it. Let's see the case for class B. For class B, you can have sublets with prefix length from 17 to 30. In fact, for the case of 24 to 30, it's very similar to the cases of the class C, except that for class B, the third octet or the third byte can vary from 0 to 255. So to get all the sublets, you just start with the third octet with 0, and then you divide the fourth bytes into different ranges, as what we have just discussed in the case of class C. And then you vary the third bytes you increase it one by one until it reaches 255. Let's see an example. If we want to divide 172.16.00/16, which is a class B address, into /26 sublets. So, because on the 4th byte, we use similar technique. For /26, we find out the size of the range first. So the numbers of host bit is 6. And then the range size is 2 to the power 6, which is 64. Then we start with 0 in the third octet, and then we increase 64 each time in the fourth octet. That means the first sublet is 172.16.0.0/26, and then the next one we increase 64 in the fourth octet. That means 0.64/26, and then 0.128, 0.192. But then what's the next? Because we don't have 0.256. In fact, we increase 1 in the third octet, then it becoming 1.0, and then 1.64, and so on, until we reaches the third octet as 255. Then we have 255.0, 255.64, and so on. Now let's move to the case of /17 to /23. In this case, you have both sublets and host bits. On the third octet, that means right now you are dividing the 256 numbers of the third octets into different ranges. But notice that one numbers in the third octet already represent 256 addresses, because the fourth octet can vary from 0 to 255. Now the range size in the third octet is against 2 to the power h. But notice that this time h is numbers of host bits in the third octet. Once you find out the range size, then the subnet numbers of the third octet will becoming the starting numbers of each range, just like the cases we discussed in the class C. Those are the multiples of the size. And then for the fourth octet, it will be 0. Then what about the broadcast address? That is the last numbers of each subnet. For the third octet, it will be the last numbers of each range, while for the fourth octet, in this case, is not 0. Instead, it is 255. As in binary, they are all ones. Let's see an example. For example, if you want to divide 172.16.0.0/16 into /21 sublets, then for the third octet, how many numbers of host bits? Is now 24 minus 21, which is 3 bits. So the size of ranges will be becoming 2 to the power 3, that is 8. Then we start the third byte as 0 and then increase it by 8 each time to get the subnet numbers. That means the first sublet is 172.16.0.0/21. But what is the broadcast address of this sublet? It will become 172.16.7. Why is 7? 7 is 0 plus the size, which is x minus 1, right? Remember that you need to minus 1. And then for the broadcast address, as what I mentioned, the last byte will always be 255. So this is the first range. What about the second sublet? Increase h for the third octet. That means it becoming 172.16.x.0, right, for the sublet number. What about the broadcast address for this sublet? You need to add the size minus 1 to the third octet, right? That is 8 plus 8 minus 1, which you get 15. And then for the last byte, as I mentioned, it will always be 255. So that is the second range. What about for the third sublet? Once again, increase the third optics with 8, then you get 16.0. And then for the broadcast address, add 7 to the third optic, that you get 23, then .255. What about the usable address? For each sublet, we have 8 numbers in the third optics. But one number I just mentioned is already represent 256 addresses. That means in this case we have 8 times 256 addresses in the range. But then the first and the last is not usable, so we minus 2. The answer is 2046 addresses. How many sublets you get? The calculation is the same. You need to know how many sublet bits you have. In this case, you have 5 bits, right? Then it becoming 2 to the power 5, which is 32. Finally, we move to the case for class A. Once you understanding class B in the previous slide, you shouldn't have problems to understanding the case for class A. I will just discuss the case for the /9 to /15. I tell you that is really unusual. You will see why. Then now you will have the sublet and the host bits on the second optic. That means right now we divide the second optics into different ranges. Notice that one numbers in the second optic already represent the squares of 256 IP addresses. That is already over than 65,000 IP addresses. In real life, we seldom require so large numbers of addresses in a subnet. Now the size of the second optic is once again 2 to the power h, where h is numbers of host bits in the second optics. For example, for /13, how many numbers of host bits there? You should use 16 minus 13. That means you have 3 bits. So the size will be becoming 2 to the power 3, that is h. That means right now you divide the second optics into different ranges with the size of x. So once you get the range size, the sublet numbers of the second optics will becoming the starting number of each range. That is once again the multiple of the size. And then for the third and the fourth optics, it will always be 0. What about the broadcast address? For the second optic, it is the last numbers of each range, or actually that is the starting number plus the size minus 1. Remember that? That's how we calculate the last number, right? And then for the third and the fourth optic, it will always be 255. As mentioned, that one numbers in the second optic already represent 256 squares IP addresses. So the size of the ranges actually represent the size times 256 squares numbers of IP address. Once again, because the first and the last address are not usable, so we minus these 2 to get the numbers of usable address of each sublet. Lastly, how many numbers of your sublets you get? Same formula. 2 to the power s, where s is the numbers of sublet bits. Let's summarize what we have learned in this presentation. Now sublet calculation is simply divide the 256 numbers of an optic into different ranges. The most important is to find out the size of each range. And the formula is 2 to the power h, where h is the numbers of host bits. Once you find out the size, then it's easy to find out the sublet number and the broadcast address. The sublet number simply start with 0 and then you add the size one by one. That means actually the sublet numbers are the multiples of the size, while the broadcast address is the last number of the range. Or you can use the subnet number plus the size minus 1 for the corresponding broadcast address of that particular subnet. Thanks for watching. If you enjoyed this video, please give me a like. I will still continue creating presentations for the CCNA and some of the CCNP topics. So please subscribe this channel, which that now you know how to do the subnet calculations in your examination and get a pass. Goodbye.